So I can do the introduction and then we'll switch over.
Whatever.
Okay. All right, this is functioning as a core projector. Let's move it over. So I think we're about ready to get started. So everybody, do me a favor, cross your fingers real quick, and that the Zoom gods and HDMI gods all work for us, because we're running a Zoom session between two laptops here to make this project up there, to get recorded, to go to another Zoom online for all the online viewers. So fingers crossed, right? That's what. So all right. So terrific. User behavior insights is this talk, formerly titled "Your Search Engine Needs a Memory." And so I am going to do some. I am going to do some introductions. So yeah, intentionally blank slide. So my name is Eric Pugh. For those of you, I'm one of the co-founders of OSC, and maybe more relevant to this crowd, I'm actually one of the instigators of Haystack, something that I'm inordinately proud about, and more proud every year seeing this amazing turnout. So yeah, so that's me. This talk is based on a presentation a couple of years ago, so September 29th, 2021, when Trey, Max, and Doug gave a panel, either gave a panel discussion about AI-powered search, or I was reading an early Manning early access version of their book. And in AI-powered search, they talked a lot about generalizable signals format and collecting signals. So I opened this issue in one of our open source repos. Wouldn't it be cool to track clicks using a generalizable signals format? So that was my interest in this, obviously dates back a couple of years. So really excited to be here. Now, co-presenting with me is Stavros. So for those of you who don't know, Stavros has got deep expertise in the search field, background at Lycos and Google and a couple of other big name companies, and done a lot of interesting things. And today he is a senior technical product manager for OpenSearch at AWS. Stavros, definitely has a certain type of humor. And I looked at my email and I enjoyed finding my first interaction with Stavros. And I think this is a classic Stavros email, very to the point, very short, but I'm learning to appreciate them. So it was kind of really just wonderful to be like, wow, you've been involved in the Haystack community for a while. And I do remember getting this email a long time ago and saying, wow, there's real interest in this conference. So a little bit of a trip down memory lane that you all could do with me. So yeah, so we're really excited here to be talking about user behavior insights. I'm going to hand it over to Stavros to set a little bit of context, and then I'm going to do a demo, everything working out, and show maybe some of the more technical bits of the work that we've been doing. So, all right, so let's do a quick handoff.
That was a lot of words. So I'm going to talk a little bit about why we need user behavior insights. And Eric's actually going to do the hard part of the work here. I think we all know, I hope we all know that search needs data. We need to know what's going on out there. It's not enough. We of course have the corpus data, but I'm not talking about the corpus data. We need data about how people are using search. What do we need it for? Well, I like to go back to a basic difference in our field between databases and search. In databases, you write your SQL query and you know exactly what should come out. It's well defined. There's no question of, is it a good result or a bad result? It may not be the result you wanted, but what is a correct result for the SQL query is well defined. That's not true, of course, in search. In search, you want the best results. And typically there are too many results to show all of them. So you can't say, oh yes, we're going to show all the results and the user can choose the best ones. We know this. I mean, this is not rocket science here. But what do you want to know? You want to know, are the results good? Did we show the good results? And what's good? You want to know which are the best results. How do you know which are the best ones? So that's one reason you want data. Another reason you want data is you want to adapt your results to the corpus, that is the collection of documents you have, and to the user population. And this slide, I'm obviously not going to go through this in detail, but the idea here is that if you look at this slide, there are huge numbers of applications of search. And we've heard about this at the conference today and yesterday. Huge numbers of applications, and each of them has a different notion of relevance. There's not a universal notion of relevance. So how do you know whether a document is relevant? You look at how people interact with it. So I would claim that the unifying concept behind search is relevance ranking. SQL is fine as far as it goes, doesn't have the concept of relevance ranking. Sometimes people say, oh, we'll just use SQL to do search. And if you have some sort of heuristic about what is relevant and what isn't, you can actually do a pretty good job. In fact, a few years ago, I had to do a company search which was like a subsidiary search within a bigger application. And we had hundreds of thousands of companies in our corpus, but we knew that large companies are of more interest to our users than small companies. We knew that companies that they had worked on before were more interesting than companies that they hadn't worked on before. And of course, the data was dirty. Sometimes the largest companies actually weren't even listed as large companies and so on. So you had to have some sort of notion of dealing with dirty data. And so what did I do? I went to my machine learning colleague and said, here's this corpus of data, and let's figure out how we can adjust the weights on different factors. No, that's not what I did. What I did was I used, I think Trey likes this tool too. I used my wet finger, put it in the air, and said, okay, I think the size of the company is probably really important, and the address is probably not important at all. I'm not going to use that, and this and that. So I had about 10 factors, and I put them in and adjusted the factors and got not so great results. Then I said, okay, well, let's make this one logarithmic. Let's make this one a bigger factor, smaller factor. And sure enough, damn thing actually worked really well. I deployed it. Actually, we didn't deploy the SQL version. I went to my engineers and said, here's a SQL prototype, do it. And it worked beautifully. So actually, SQL is a great tool if you know how to rank things. But again, I'd say that search is relevance ranking. And usually you can't do something as simple as what I did. You can't say, oh yes, a lexical search in the description is worth half as much as a lexical search in the title or whatever, all that sort of thing. So what's our goal with user behavior insights? Our goal is to collect all the information you need for evaluating search based on user behavior. Now, why is that hard? You think, well, I can go to large company X analytics or large company Y analytics and buy their solution, and that gives me the information I need. Well, most of the analytics solutions on the market are about aggregate data. They're about telling you what proportion of the users use this page, how often did they hit the back button, things like this. As far as I know, there are no good solutions for us, the search community, that are especially not available in open source. I mean, I suspect there are some that are proprietary to some of the other vendors, but not something that's available in open source, not something that could be used by anyone. In fact, one thing that I should probably mention now is that our solution is not linked to OpenSearch, the product, or OpenSearch, the code base. It can be used with any search system. And we'd like to make it usable for everyone. So what kinds of questions do we want to ask when we're evaluating search? You want to say, what did they search for? Okay, that's an easy one. Usually you can log the searches. That's not so hard. How did they use type ahead? Okay, we can probably do that. How did they refine the search? What's the sequence of facets they used? Which facets did they hit first? Which did they hit second? How much did that reduce the result list each time? Getting a little harder to do using standard analytics techniques. What search or what search or sequence of searches led to a particular purchase? So if I'm the category manager for slippers and I want to know red slipper number 235, how do people find it? Are they searching for red slippers? Are they searching for warm slippers? What exactly are they searching for? So you can search backwards and say, starting with the thing that was bought, how did they end up buying it? How did they find it? And that may involve not only the sequence of events after the search, it may involve the sequence of events before the search. So they may have done previous searches, they may have looked at recommendations. You want to see what the user was exposed to before they did the search. And of course, you want all the actions. I mean, that's the sort of the obvious part. You want to know they clicked on this, they hovered over on that, they hit the back button, all that kind of thing. And so that's a lot of data. And say it's 2024, guy. The famous Google video where someone says, "I want to serve 5 terabytes," and the answer from this system reliability engineer is, "I can't remember how to count that low anymore." So these days the data volume is not an issue, and we have a lot of experience at OpenSearch certainly, but also all our competitors have experience with very, very voluminous log data. So the infrastructure, I got a pop-up. Auto update. What is out of date here? Oh, thank you, Amazon. These things happen at least once a week, by the way. Yes. So what was I saying? All right. So we know that we want to collect lots of data, and say, well, maybe people are already collecting this data. Maybe this is a solved problem. So my boss Eli and I, 2 years ago at Berlin Buzzwords, where there was an unconference, and so we got a bunch of people, about as many as are in this room today, and we asked them, what are the important things that every search implementation should do? Okay, so we did the usual post-it note thing and voting and all that. Then I think it was Eli's idea to ask the second follow-up question, which was, so how many of you are actually doing these things? And a different set of hands went up. That's an interesting data point. And the list here on the left is organized by the gap. How many of you think it's important but aren't doing it? And the first thing on that list was logging actions on search results. The first thing on the list. So as a product manager, I want to listen to people and say, okay, sounds like that's important. Sounds like people aren't doing it, aren't happy with the way they're doing it. And there are various other things like understand the application data. We've heard about that here too, where you actually want to know what are the semantic relations. This field that says company, is it standardized in some way? Is it the same kind of company name that appears in this other field, and so on and so forth? That was the second. Third was evaluating the quality of the results, which comes back to using this data. And then there are various others which are also important, but not really the topic today. So that was interesting. But of course, at Brilliant Buzzwords, you see a lot of middle-sized, small companies, amateurs, people like you who don't really know what they're doing. Sorry. But I thought, well, let's look at our real customers. Let's look at AWS customers. So I spent quite a while. It took me longer than it should have. But I spent some time talking to our salespeople and saying, I really want to get into meetings with people who are using search. And the reason it took me a while is that they didn't quite understand that. They didn't quite understand the notion of search as opposed to other applications of open search. They didn't quite understand that relevance engineers are a different population than operations engineers. So it took a while to get to the right people. But finally, I got to the right people at various companies. And I sort of discussed with them, well, what are your challenges? What are you up to? What can you tell me about your philosophy of search and so on? And the first thing I discovered was that actually very few people think of themselves as search relevance engineers. They think of themselves as software engineers. Say, ooh, this is a problem, right? Here we are. The people who come to this conference are the people who actually realize that it's a discipline. These are people who don't realize it's a discipline. So that's a serious problem. But then the second thing I noticed was they all had problems with logging. And I talked to some very large companies. You'd have heard of them. I'm not allowed to tell you who they are, of course. And some of them would say, well, tell me a little bit about your logging. Do you log, let's say, what people click on? Say, oh yeah, of course we log what people click on. Great. Do you log what people don't click on? We hope to. Okay, so you don't log what people don't click on. So you do know what position people are clicking on. Well, Joe has some prototype code that does that, but I'm not sure I trust it. Okay, go to another company. I said, do you log things? So, oh yeah, we have some logging code. Now Eric wrote it a couple of years ago, and it seems to run fine, and it collects the data. And so, well, what if you want to change it or improve it? Well, Eric left the company, and no one really understands his code because it's spaghetti code. But so, we have a solution, but, if something better would come along, we'll take it. Go to another company, say, do you have a logging solution? Say, well, we have a pretty good logging solution, but it's such a pain. We have to assign someone to revise it every time we change this and such. And it's really not our business to work on logging. That's not where we make our money. We make our money in whatever we do. We sell chocolates, or we find people jobs, or whatever. So there was clearly an appetite. Quality evaluation was even worse, by the way. So even fewer of these very large companies that you've heard of with large search teams didn't know how to evaluate the results. Shocking. They also didn't know how to use multiple signals. Again, very large companies, you say, have you thought of using popularity as a signal in your ranking? You can do that, All right, but that's, again, orthogonal. So this is the diagram I like to put up when I talk to customers and even to you. And you see on the top left, you have what I call search processing. These are all the techniques you use to create search results. And people love to talk about these techniques. People spend lots of time talking about these techniques. In fact, most of what goes on at this conference is also about these techniques. Are you using vector search? Are you using, what sort of tricks are you doing with lexical search? How are you doing hybridization? How are you combining hybrids? Are you using sparse neural, which also called splayed? All this stuff. People get really excited about the stuff at the top left. And I said, that's great. Then what? Do you evaluate the results? Well, who has the time to do that? And again, in talking to these very large customers, you say, well, there's a gap. And so we've been thinking a lot about the top right, which is measurement. And one critical component of that, it's not the whole thing, but one critical component of that is getting the raw data. So that's the problem we've decided to focus on. And then once you have that, you can start working on tuning. You say, okay, we'll adjust parameters, whatever. So these are the various search processing algorithms that we all know about. And I don't think I need to go into too much detail on these today. Oh, by the way, just because I'm such a cranky guy, I'll say I insist on lexical search, not keyword search. Keyword actually means something very specific, and it's not the same thing. Damn it. Anyway. So what is user behavior insights? It's about recording the end-to-end search behavior in a standard way. And in working with Eric and his team, we have some principles that we work on. The first principle is that the most important thing we're doing is standardizing the schema for the events. That's not even a piece of software, just agreeing on what words mean, basically. The second thing we're doing is providing the software to collect those events. And the third thing we're doing is helping analyze those events, because once you have the data, analysis should come fairly easily. And there are various ways of using it, of course. How to use it, you can tune manually. I mean, the finger certainly needs some data. You can do Bayesian parameter optimization. You can fine-tune your models. But all of these things depend on having some data on how good is the result. Learning to rank, of course. And my favorite, combining neural and lexical, excuse me, well, that's a typo. It should be neural and vector rankings. So all of these things require data to help you get the right results. So what does UBI let you do, user behavior insights? Well, there are all sorts of applications. You can dashboard, and managers love dashboards. I don't find them that useful, to tell you the truth, but except when there's a bump, you say, oh, gee, that's funny. Why did that change so suddenly? Investigation of particular problems by relevance engineers, data scientists. Collecting judgment for offline evaluation. So even though we have all this dynamic data, we do still want to do offline evaluation. So where do you get the queries for offline evaluation? You get them here. Debugging, tuning of all sorts of parts, so type ahead and so on. Real-time feedback to relevance feedback. So I'll mention that we're working with another team at Amazon called the Personalized team, which has a non-open source product. So it's another part of Amazon. We're happy to work with them. We're happy to work with any one of you. We want to make sure that the data we're providing will allow in-session adjustment of results. So our solution is near real time. And of course, we all know that you need this data as input to machine learning models. That's the sort of obvious thing. So what's this project? Well, Eric and I discussed this, I think, 2 years ago at Haystack, or actually at Mices at Haystack 2 years ago. And I buttonholed him and said, Eric, why don't we have a standard way of reporting this data? And he said, good idea. I said, okay. And so we put out an RFC in our GitHub in 2022. We revised it this January and updated again just last week. The community debated names. We make frequent presentations at the Open Search community meetings. So this is all community feedback based. All the work we're doing, all the software, all the discussions happen. Well, I occasionally talk to Derek without recording our conversation, but the discussions happen on GitHub. And everything we're doing, everything we're delivering is under the Apache 2 license. So now it's Eric's turn to show what we're actually doing.
All right, so quick change. Hopefully we got 19 minutes. All right. Here's your phone, Stavros. And we believe the left side works better. All right. I'm going to grab this laptop right here. All right. We got audio, video. All right. Fantastic. So, all right. Y'all can hear me. Terrific. So thank you very much, Stavros, for kind of setting the context of everything in my notes. So, all right, great. So, yeah, so, right, thank you. All right, so really quick, right? So Stavros talked about how we're getting information. We're looking for community feedback. And so just 5 questions, right? Really simple survey. We'd love to have some feedback from all of you on kind of where you are, and we will post the feedback. It's just a couple of scores in the relevance Slack Haystack channel. So everybody got that? And if you don't have it, I can do it later. So obviously this is very personal to me. And so I kind of wanted to share why I'm excited about UBI, right? And why this has been such an interesting journey to go on. Some of you may have seen this diagram at other Haystack conferences. It's one I use all the time. It's how I think about, relevancy improvement. And, we got our two wheels. We have our lab offline environment. It moves really fast. It evolves. We try things out. We, use this great data. Thanks for the shout out about implicit judgments and stuff for offline testing. And then we have our live online environment. And it's big. It's where we really validate that our experiments and ideas are actually what our users agree with, right? And what I find is that there's often a gap, right? The clickstream portion of it is a gap. And as a relevance engineer, right, it's sometimes difficult to work in that space. It's a separate team, it's a separate product, a lot of the issues that Stavros kind of highlighted. And I find that without the clickstream being really robust and really designed for what I need as a relevance engineer, it's difficult to do my job, to be effective, to run both sides of the relevancy framework. So I was digging around. I actually found the copy of this slide from 2021 and 2020. And there's 2020 Eric saying, ugh, Google Analytics. That's what I got. That's what I got most of the time, right? And it kind of sucks. So I am incredibly excited about working on an opportunity to improve, to fill this gap in with something that is meant for us. So there's three parts to this sort of user behavior insights project. Obviously, some code for collecting specific events, right? We've all been out there. We've seen the little bit of JavaScript or something in the middle tier, whatever. We have to collect some events. And we've really been trying not to build that ourselves because honestly, everybody's going to want to build their own anyway. But we do have sort of a goal of providing a starter basic JavaScript client for those that people could use. But definitely an area where there could be some great contributions from the community. Now, a big area that we spend a lot of time on, we want a shared schema, right? We need a way of defining what the users are asking for and understanding what is a query, right? And, we're trying to, what is the user query? We need to also have a good way of tracking and articulating back what are the documents, objects, records, chunks, what are the things that we are returning back to the user, right? Because that's as important as understanding what your user queries are. And then, of course, what we're trying to do is build a strong, I think Stavros likes to use the word causal relationship, a causal connection between the user did this query, they picked these facets, then they did these things. And we want to do a better job of making that breadcrumb journey clearer and more visible than maybe some of the other tooling that's out there, especially the things that are specific to us in our industry. And then lastly, of course, right, we're starting out with making an implementation in OpenSearch. I want to make a quick shout out to my colleague Jeff back there. Raise your hand, who's been leading a lot of that effort and has been really awesome. And yeah, really appreciate Jeff. So of these three things, though, one of them is more important than the other two. It's that shared schema, right? And this is where we're really hoping to get a lot more input from the community. Is this a schema that you could use? Is this something that makes sense? Are we rich enough in the places we need to be really rich? Are we extensible enough in the places we need to be extensible? Or are we too extensible and it's impossible for you to build a decent dashboard or visualization on top of this? And maybe we need something less extensible and more structured, right? The value in this project, right, is coming up with a shared schema that we can all use. So really quickly, wanted to throw up a quick diagram before I do a demo too of what this looks like, right? Not too surprising, right? We start out and we have a query. You type in something in the search bar. We're sending a query to, in our case, OpenSearch. So _search in the other request handlers. We're actually working on componentry in there to intercept that query and the documents that are going to be respond. And we're actually writing them out to an index in the background, right? It creates a UBI or UBI queries and UBI events index right there in your OpenSearch. So just without doing anything else, if you start using this, we're going to start building a view of when queries happen, what documents are being returned over time. Now, we're going to return back to the front end, however that looks like, a query ID. And the query ID is a unique indicator, right? This is the thing that helps us, that allows us to tie together the query to the return documents and start building a view of, and then what did the user do? What did they click on? What did they not click on, right? That query ID is sort of the key bit. Yes, it's some state, right? It's something we have to manage in the front end, right? We have to accept that to be successful in this, we're going to have to work with in the front end. We can't do everything just on the back end. So there's our 3 results. We got 3 documents, right? Result A, B, and C. Our user, clicks on result C. That's the one that is attractive to them, right? They like that one. We go ahead and we log that click through back to our UBI index. We bring up our detail view. We're still preserving that query ID, right? It's sort of the query ID, which would let us understand what facets had they picked, what search query had they done, all of that sort of state or context for their search. We love result 3. It's exactly what we want. We're really happy. We click our add to cart. Same query ID, but a new event getting logged into our back end, right? That looks like a positive signal for whatever that query and set of documents were. And, interestingly, result C might be a better result than B or A because the user picked on it, clicked through it, and then bought it. So just one slightly different view of the same thing before everybody says, wait, you can't write everything directly to OpenSearch, right? I think that one of the interesting things, we're looking at, data prepper is a endpoint for bringing data in, right? And you could imagine that we are gathering our events from OpenTelemetry queue, S3 buckets. Maybe you have an existing analytics tool that you really, really like, and you're just not going to change it. But if we have the query ID in there and maybe we can intercept that and bring it back into OpenSearch. One of the things I'm really curious about or want to hear is anyone who is doing sort of in-session personalization, where maybe the near real-time aspect of writing events directly into our UBI events directly without going through sort of a batch or a queue might actually be useful for the next query. I can inform it by what you just did or your previous clicks, right? Be interesting to see that. All right. So I'm going to go ahead, give a quick demo. Hopefully everything bears with me. All right. So some of you all may have seen this. This is Chorus. It's our reference implementation for e-commerce search. We have a number of flavors of it: Solar, Elasticsearch, and now OpenSearch. And in this particular one, I have it set up. And so you can see there's my user ID, my session. I'm going to go ahead and open up the console and turn off errors, warnings. See, right? And so, this shouldn't be a big surprise. I clicked in the search box. We're kind of aggressively in this POC logging everything, like every click and everything. This may not actually, despite what Stavros said about his terabytes and petabytes of data, we might not actually want to log every mouse click and everything else. It also makes for a rather jarring experience. But, there I am, laptop. Right there I am looking for laptops, and you can see that I've got some on search events and I'm logging things. In the background, I have logged that for this query laptops, these are the doc IDs that we're returning. We're not logging every document that matched. We're just logging whatever your row setting are, right? Because what we really care about is not every document. What we really care about is documents that users could interact with, right? Because that's what's really important. We're focused on the query and the user. And, if I go in here and, all right, I'm going to pick some HP laptops, see what we got, right? There should be, where's my, okay, oh, there we go. Just took a second, right? I can see that, and you can see the events. Okay, makes sense. Kind of straightforward, right? Okay, all right. So moving on. So where is all this data going, right? So we are leveraging our OpenSearch infrastructure. So let's go ahead and just take I'll take a quick look-see at our queries index here. And so there you can see the structure of our queries. And let me scroll down. That's a little bit of a nicer one, right? So there you can see that we have a query ID. For that user, we're actually currently logging like the raw query as like what OpenSearch is getting. What we've realized is we actually really care about what the user typed in, not, there are other tools that could tell us about the expanded Lucene query. But, there we are. We got our query ID, and there, right, is a list of the documents that are being returned to the front end. Okay. Sort of similar structure for events, right? There we go, right? You can see we did a product hover, what the last query ID was prior to this. We have some various sort of message and info and, an event attributes data structure in here. So, all right. So you can see it works, but how would I use it? So Stavros did highlight that one of the groups that's very interested in this is the personalized team, right? And in the personalized team, they need to know a user, they need to know an item, they need to know a timestamp, and they need to have some sense of what like the interaction was, right? So let's see if we can query that. So here we go, right? Right here. So there I go. So I've written. So go ahead and grab my ID as the user ID column that they're looking for. There you can see we're digging into our event attributes and grabbing the object that we're interacting with, right? And we're grabbing out the item ID. Obviously, we got our timestamp there. And then, our action name and some messaging. And specifically, right, the personalized team, at least right now, hasn't said global hover or every click they're interested in. They're interested in certain events, right? And so, an add to cart event obviously is probably a pretty strong signal. So we are just filtering it down for a specific user, just for purposes of this demo, and then, what the action is that we're looking for. Here we're doing add to cart. Go ahead and run this. And there we go. And so what's interesting is if you look at this data, right, is this user is clearly interested in technology products, right? Because they keep adding them. Is there anything else that you might notice about this user? Any other preferences that they might be expressing just by looking at the types of products that they add to their cart? HP, right? Thank you very much, Maya. Right? She understood the assignment. So yeah, right. This is really interesting. Right here, right? I am seeing that this person has a proclivity towards HP products. They like the notebooks, the parts, the desktops. Not that there aren't other brands in there, but they like the HP products. So potentially, an interesting experiment to do with this data would be to boost on the HP brand, right, in subsequent queries, because they clearly, they seem to have an affinity. Okay, excellent. And my laptop's going to die right about when I'm supposed to be done. Okay, so that's great. So that's where we are right now. So the way we're enabling these queries, for those of you who are curious, thank you, Stavros. You're a good man. We've kind of gone around a couple ways, but we're adding a stanza UBI. And there's sort of an example of what we really care about is the user query. The wind rises, not the expanded query that went through the merchandising layer and exploded it into the query string that you see there, right? And so if we see a UBI clause in there, we enable the UBI function in OpenSearch. One of the things we've heard from a couple of people, though, is a lot of people are going to want to manage that query ID, right? It could be a GUID, and if you don't provide one, you get a GUID. But maybe you want to put some context in there, right? I think this is a point of debate or question. Is it a good idea to embed some context into your individual query ID and manage it from outside? I don't know the answer. I'd love to talk to more people about it. But there's sort of an example. We're sending that in. Now, on the indexing side, so the demo I showed you was built with OpenSearch 2.13, came out a couple of weeks ago, and we actually wrote a plugin for OpenSearch, and we actually had our own endpoint on that plugin to receive events. But the feedback we got and looking at it is everybody is going to want to manage that event pipeline in different ways, right? And so mandating you must use this one plugin endpoint, I mean, it was nice from the perspective we could maybe enforce a schema and do some other things there, but it also hurt us on supporting like scalability and different approaches. So we kind of took a step back, and in the next versions of OpenSearch, what we're saying is we're just going to be another index like all your other indexes. And so we're going to piggyback on your indexing pipeline that you already know and like. You could post events directly in, like I'm showing here, or you can do, write to an S3 bucket and use Data Prepper to suck it in and then write it. So that's how we're doing it. So I'm going to be sharing these slides, and one of the things that I want to highlight is we've written a fair amount of documentation around the schema because that is the thorny bit in this. Yeah. All right, I got just a moment to finish this up. So I know what you all are thinking when we talk about we ought to have a standard, right? Yeah, you're all thinking this, right? 14 standards, and now we have 15. But what I am suggesting is that at least in our industry and what we're doing, this is the actual situation. There are no competing standards, right? We have 0 competing standards because we don't have any standards. Everybody is separate. But maybe if we're successful on this effort, we could have one cooperating standard going forward. So we'll see. There's your QR code to bring up this page if you want to try out some of the links. The RFC is public. We're looking for commentation. We've gone through 3 revisions, so we're looking for comments, but productive ones. We got some documentation. We have the schema. The demo that I showed, that's the repo there. It's a Docker image with a quick start shell script. And of course, we have an online demo. Try out those links. You can bring up exactly what I just did. So yeah. And so I'm super excited that at the end of this journey, maybe I can close this ticket to track clicks using a generalizable signals format. Thank you. I don't know that we have time for questions, Scott, or?
Do you have one online?
All right. Oh, excellent. So in terms of data collection, have you devised a loose coupling for endpoint data ingestion into pipeline, right? Airflow, Kafka, et cetera. I think that the answer is that's why we're not doing our own plugin with our own data collection endpoint and just being plain old open search, right? Because everybody's going to want to do that differently. We're going to be demoing it with Data Prepper, right? We're going to demo it with some JavaScript that people can use, right? But people who are like, we use these technologies, we should be able to adapt to that very quickly, right? So.
Who's managing the question? Are you managing the question?
Yeah. Sneak up there.
Performing aggregations, rankings, comparisons, summarizations across multiple objects. So I think there's
this
two ways
seems
that things could go.
closely,
One is
tangent to A/B testing in a variety of ways. There's also latent signals that come out of A/B testing, like how long does your user sit on a page before they do an action?
Right.
That seems like they should also be included in this.
Well, everything is timestamped. So all the
Okay.
actions are timestamped. So latency is certainly something you can measure.
Right. And then the other bits and pieces of this are when dealing with personalization, at least in the company I work for, that's very difficult because Google's really effectively trained our users. If they don't see the first three results, what they want, then they'll put in another query, and another query. So unless you can apply that result to analyze the queries fast enough to do the personalization, it's hard. This seems
Absolutely.
like would work really well when you have users that are well trained to look at a bunch of stuff.
Yeah.
And so maybe it would be nice to think about a small result set version.
Right. Yeah. No, I love that idea. I mean, I'm super intrigued by the in-session personalization. I'll admit it's a little out of scope of what we're trying to build here. It's, I think, a great use case and one I'd love to hear more about because of exactly those challenges. Right.
Yeah. For now, we're looking at like seconds of latency, which is not enough to handle the rapid fire queries. We do hope that we'll get it down to under a second, but that's aspirational.
Yeah. You want to get another question while I try and
one
find?
Hey, thanks so much for your talk. I'm gonna be, it's the best one I've been to in this section. So I'm a data scientist. I work on the search team at Reddit. I just want to confirm that this is a great track and I can't wait to look into it as well. We went through a similar journey in-house probably about 2 years ago, and we ended up with a lot of similar concepts and constructs that y'all did. And from the cooperating standard, I believe a great route would, and you're probably heading this way, but the schema is essentially what I would call like the core schema. And then any implementers can have their own secondary schema that would have domain specific aspects as well.
That's exactly what
So,
we have.
okay,
In fact,
yeah, perfect.
So we have the course schema, which basically you're saying, we recommend that you report at least these things,
Yeah,
which lets you do these kinds of analysis.
that's right.
Beyond that, we have optional things. And our goal is to define all of these fields in such a way that if it's a well-defined field, you know what you should put into it.
Right.
It's not required. Nothing's required, but you should at least know what goes in there. And if you have a user ID, you know what a user ID is. And the notion of a user ID is simply a unique ID, even if it has internal structure. The internal structure isn't our business.
Yep, great. I'll leave that. I'll follow up with you all personally.
So I'd love to have your feedback on site about, since you have the experience with the sort of thing at Reddit.
All right. Thank you, Eric. Thank you, Stavros. We have a round of applause, please.
Thank you.
All right. We have another 15 minutes before our next talk.
Okay. You, Scott. Bringing us home, right?
Yeah.
3:45.
Clean up better. Okay.